All right, let's look at our next problem. Again, what we're looking at are College Board problems. So we've looked at 2012-1, and now we're looking at 2012-B1. Both of them are question 1 on the 2012 test. Just one's from the national version, one's from the international version. Not really supposed to be any difference between the two tests, but sometimes there's a slight difference in maybe the way the questions are worded, but it's not anything too dramatic. So let's kind of go through and see what we can come up with for these. So we have methylamine, CH3NH2, is a weak base that reacts with water according to the equation above. Student obtains 50 milliliters sample of the methylamine solution and determines the pH of the solution to be 11.7. First thing it says is to write the Kb expression. This is a easy giveaway point. Make sure we get this. So we have our products, which are these guys, over our reactants. Okay, not too bad. And you can replace the Kb with a 4.4 times 10 to the negative fourth. That's perfectly acceptable. It's kind of up to you how you do it. So A, easy, 1 free point, good to go. B, calculate the molar concentration of hydroxide in the 50 milliliter sample of the methylamine solution. Well, a lot of times we would do this by doing an ice table, but they help us out. They already gave us the pH. So remember pH, if we go back and think about it, equals the negative log of the hydrogen ion concentration. Well, that doesn't help us with the hydroxide ion concentration, but what can we do? We can recognize that POH equals the negative log of the hydroxide ion concentration. So we can find our POH. Okay, and if you remember how to calculate POH from pH, you just take 14 minus the pH, which is 11.77, and that's going to give us a POH of 2.23. So we can set up that equation. 2.23 is going to be equal to the negative log of the hydroxide ion concentration. Okay, first thing we have to do is get rid of the negative sign, and we bring that over. Next thing is we have to basically get rid of the log, which means we take 10 and raise it to the log of hydroxide, and 10 raised to the negative 2.23. So what we end up with is the hydroxide ion concentration equals 10 raised to the negative 2.23 exponent, which gives us a concentration of 5 looks like we've got 3 sig figs for all the main numbers I'm seeing. I'm not using Kb. Actually, with our pH, we have 2 sig figs, so I guess we'll work off 2 sig figs. So 5.9 times 10 to the negative third molar is our concentration of hydroxide. Okay, so not too bad. Moving on to part C. Calculate the initial molar concentration of the methylamine in the solution before it's reacted with water. Okay, well this is different. We actually haven't done one of these before. But it's actually not that bad. It's almost kind of like a backwards design problem of sorts. So first off, we have a reaction, and this is just the reaction from above, just right here. I'm just rewriting it down here to be able to use it. Okay, so what we're really trying to figure out is our initial concentration of this guy, which we're typically given, we just weren't given it today. Well, let's kind of we'll call it Z, just to make our life easier. And we're going to treat it like we normally do an ice table. And let's just kind of go through this step by step and see what we come up with. So Z minus X would give us Z minus X. We don't care about water. We would have our plus X over here like we always do, and X and X. Well, what do we know? We actually already know what X is. We just calculated it in the problem above, like 5.9 times 10 to the negative 3. So what we can do is we can now plug that into our equilibrium expression and actually solve for Z. It's kind of, like I said, a backwards design problem. It's a little bit different. So let's go back up here and grab our Kb, 4.4 times 10 to the negative fourth. So we have 4.4 times 10 to the negative fourth. That's going to be equal to 5.9 times 10 to the negative 3, our X, times X, 5.9 times 10 to the negative 3, divided by Z, minus 5.9 times 10 to the negative 3. And we can just solve this algebraically. And what you should get, from here is the original concentration is equal to 0.085 molar, again, keeping with 2 sig figs. So make sure you can do this math. Basically, I'm multiplying Z minus 5.9 times 10 to the negative 3 on both sides, then dividing by the 4.4 times 10 to the negative 4th. I'm not distributing it to the Z or anything like that. I'm just going to divide it right over. Solve this out, so 5.9 times 10 to the negative 3 times 5.9 times 10 to the negative 3 divided by 4.4 times 10 to the negative 4th. So this is now over here, this guy's over here. And then add the 5.9 times 10 to the negative 3 on both sides. So again, we get 0.085. Make sure you can get that. Okay, so moving on, we get to the next part. We have 50 milliliters of the methylamine solution is titrated with hydrochloric acid solution of an unknown concentration. The equivalence point of the titration is reached when 36 milliliters of hydrochloric acid is added. The pH of the solution at the equivalence point is 5.98. So let's just make a note. This is below 7, which means we're dealing with a weak base, strong acid titration, which we know. Methylamine we already know is a weak base from our math up here. HCl we already know is a strong acid. Just kind of need to be thinking about what pHs at the equivalence point stand for. If the pH at the equivalence point is 7, strong acid, strong base. If it's above 7, weak acid, strong base. If it's below 7, weak base, strong acid. Okay, let's look at part D. D says to write the net ionic equation that represents the reaction that takes place during the titration. In other words, how does HCl react with the methylamine? So let's go back up here and grab what methylamine is. Methylamine is CH3NH2. So we have CH3 NH2. It's going to react with HCl. Well, what part of HCl is it going to react with? It's going to react with the hydrogen, because remember, HCl is going to dissociate completely, forming hydrogen ions, chlorine ions. We don't care about the chlorine ions, we care about the hydrogen, so it's just going to react with the hydrogen. And what we're going to be left with is CH3 NH3, the conjugate acid of the methylamine. Okay. The next thing, it says to calculate the concentration of the HCl in the solution used to titrate the methylamine. How in the world are we going to do that? This is where our knowledge of the equivalence point becomes really helpful. We know at the equivalence point that the moles of the acid are equal to the moles of the base. Well, what equation do we know that can help us do that? MAVA equals NBVB. Molarity of the acid times the volume of the acid is going to give us the moles of the acid. Molarity of the base times the volume of the base is going to give us the moles of the base. And they just happen to be equal to each other at the equivalence point. So we can do some basic math here because of the information we were given. We were told the volume of the acid is 36.0 milliliters, and we can leave it in milliliters as long as the other one's in milliliters. We're trying to find the molarity of the acid. Well, that gives us the molarity of the base times the volume of the base. Well, molarity of the base we already calculated is 0.085. Remember, we got that from up here. Okay, that's what we just calculated in part C, if you remember correctly, molar. And we know we used 50 milliliters of it in this titration. So now from here, we just solve for the molarity of the acid, okay, which gives us 0.12 molar for the HCl solution. Not too bad. All right, let's keep going. Using the axis provided, sketch the titration curve. Uh-oh, we got a titration curve we got to draw just like on your lab. That results from the titration described above on the graph. Clearly label the equivalence point. Okay, so 3 main points that we have to kind of get here. First and foremost, starting point is our first thing. Starting is before the titration even starts. The second main point that we typically want on here is the equivalence point. And the third point is some type of ending point, meaning after the titration, after the equivalence point, really. So guess what? They've given you all the information you need. You just have to go back up and grab it. So our starting point is before any titration occurs, meaning we just had the methylamine. Guess what? They give it to you. It's 11.77. Okay, well, let's go back down and mark that. All the way back down. 11.77. So somewhere around here is our starting point. And let me grab a different color so you can see that a little better. Let's use red. Somewhere about right here. From here, we have our equivalence point. Well, guess what? That was in the second set of prompts. We're told that the pH at the equivalence point, two things, occurs at 36 milliliters of HCl added and at about 6 as our pH. So let's go back down here. 6 is our pH. Sorry guys, it's spazzing again. There we go. Are we going to stay? Yep. 6 is our pH, and 36 milliliters. So about right here. Go up and find those 2 points, and our equivalence point is right about here. And then from there, we're going to continue adding HCl. They don't actually care where your ending point is, so we don't have to calculate it, as long as we know we're ending down here somewhere. So what does the titration curve look like? Looks a little bit like an S, where you have the equivalence point in the middle of a straight line. So I'm going to start with the middle of that straight line. And of course, you know I can't draw to save my life, so it's okay if you can't either. We have our nice little pretty straight line. It's going to come down and swoop, something like that, probably a little bit prettier than that. Something like that. And I know this is going to come kind of slowly down a little bit at a time until it reaches it. Something along those lines. Hopefully yours looks a little better than mine does. Okay, and that's it. Just so you're aware, on the College Board answer key, and you can look this up for yourself too, they looked for 3 points. You got 1 point for starting between 11 and 12 at your pH. 11 and 12. Check. Okay, you got a second point for your equivalence point being shown, and the equivalence point is shown at that straight line being about that middle of that straight line, so right about here. The equivalence point being at 36 milliliters added and around a pH of 6. Check, we got that. And of course the third point is really, in this case, is just the general shape. Okay, so general shape. So those are your 3 points for this particular problem. Easy peasy, or at least for part F of this particular problem. Not too bad. These problems are not as scary as you seem to think they are. Keep going through and playing with some of the other problems I've got linked onto the Canvas website. Hopefully these videos help, and we'll see you guys later. Thanks.